Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 163. Page 163, problem number 78. Problem number 78. Let's take a look at it. It says in a rectangular box, three sides are shown, and they give us the area of those three sides. So let's draw the rectangular box. Something to this effect. And they're showing us three sides. Now they call this side, they're calling it side 1 and side 2 and side 3. Technically speaking, most mathematicians would prefer to call these things, instead of sides, they would prefer to call them faces. These are called faces. This is phase 1, this is phase 2 and phase 3. A rectangular box or a cube has 6 faces. They're showing us 3 faces, and they're telling us that the areas are the areas of the 3 faces are 12, 15 and 20. Now it doesn't matter, it really doesn't matter which one you call the length, which one you call the width, and which one you call the height. Do you know why it doesn't matter? Because we're going to multiply them, and when you multiply the 3 numbers, or any number of numbers, or when you add them, it does not matter. The order doesn't matter. So it doesn't matter whether we call this length and width, and actually it does actually make it more convenient to call this thing height, only to honor the convention. The convention dictates, the tradition dictates that I call this a height, because that's how high it is. This is the width. And typically we call this part the length, the part that is sitting around, and this is the width. But as far as the math is concerned, it really doesn't matter. So here I'm going to pretend that the length times width is 12. Length times width is 12, I'm going to pretend. And then length times height, let's call it, length times height. So I'm going to break this up into, say, 3 times 4. 3 times 4. And length times height, we are told, is 15. And since this is length and this is length, I have to put the same number first, so it's 3 times 5, so I'm pretending the length is 3. I'm just pretending it. It doesn't matter actually. It's going to work out fine, don't worry. And similarly, finally, height times width. And the height here, I'm using that as 5. This is our height, so height times width, which was 4 right here. Width was 4, you see? This is the width, and this is the height. The height is this part. So height times width, so this is 4, that's 20. So that's it. I should have written the other way around here. So 20 equals height, which is 5, times width, which is 4. So that's it. So now we have the length and the width and the height. The length turns out, let's put a triangle around it. The length turns out to be 3. The width is 4 and the height is 5. Therefore, the volume is length times width times height, which turns out to be 3 times 4 times 5. 3 times 4 is 12, 12 times 5 is 60. That's all it is. Now you might wonder what would have happened if we had used a different configuration. But there's no need to wonder. Let's do it out and find out. Let's do it out and find out. I'm going to do it right here. So again, length times width. And instead of pretending the length times width is 12, you can pretend it's 20 or you can pretend it's 15. It doesn't matter. Everything is going to be the same as before. Nothing is going to change. Length times width, except what we are calling length and what we are calling the width and what we are calling the height. Those numbers are going to be different. But these are just names. It doesn't matter. It's the same thing. So let's do it here. Length times width. And instead of pretending that it's 3 times 4, I started out with 12, let's start out with 15. Let's start out with 15, and I'm going to pretend is 3 times 5. So now the length is 3, the width is 5. And therefore length times width, the length times height, length is already 3. Now listen carefully. Since the length is already 3, I cannot use 20. We cannot use 20 here because 20 does not divide into 3 evenly. We need some multiple here of 3. 20 is not a multiple of 3. 12 is. 12 is multiple of 3. The 12 has to go there, which means this has to be 4. This has to be 4. So our height is 4. And that's it, we're done. That's it. So length times width times height. The length is 3. The width is 5. And the height is 4. You see, just the order changes, but the answer does not change. And I left out width times height. Width times height. Width was 5. And the height was 4. The height was 4. We put a triangle around it. You see, it doesn't change. And there's a third scenario. We could have done it the third scenario. It wouldn't really change anything. But I'm curious now to see what happens in the third scenario. So I want to do it out of the third scenario. Here's the third scenario. Length times width. So first time we have started out with 12. Then we started out with 15. Now let's start out with 20. So that's 5 times 4. Or 4 times 5. It really doesn't matter. So length is 5 in this case. The width would have been 4. Alright. So length times height. Since length is 5. We can't use 12. We have to use 15. So it's 5 times 3. Which means that we just established that the height is 3. That's it. We have our 3 dimensions. And finally, width times height is going to be, since width is 4 and the height is 3, there is your 12. And again, in this case, the length times width times height is going to be, the length was 5, the width was 4, and the height was 3. It's the same 3 numbers being multiplied in different order. Whether you do, I erase this part here, length times width times height. In this case, the length was 3 in this example, the width was 4. So here, watch what happens. Here it was 3 times 4 times 5. Here it was 3 times 5 times 4. Here it is 5 times 4 times 3. It's the same volume. So don't worry about it as to where to start out with and which side to call what. It doesn't matter. That's what our thing is. That's what it is. Which is why I did not bother to put the numbers, because they are of no significance. It doesn't matter where I put these numbers, as long as you're able to identify the 3 different sides, regardless of which scenario you start out with. That's it. We're done. The answer is 60. Now the way we just did now, the way we did this problem just now, to be perfectly honest with you, was a bit childish. It was a bit babyish. Should we do mathematical way? Should we do it the proper way? I need both my hands to the proper way, the academic way, the algebraic way, the way your math teacher there will approve of it, instead of doing the trial and error. Do you want to do it? Let's do it then. All right. So they tell us that the area of the 3 faces are 12, 15, and 20. So again, I'm just going to pretend length times width is 12, length times height is 15, and width times width times height is 20. As I already explained to you, it doesn't matter, okay? The question is, what is the volume? Well, in order to find the volume, here's what you have to do. Here's what you have to do mathematically. Length times width times length times height times width times height, in this case, equals 12 times 15 times 20. And this length, there is a length, there is another length, the length is squared, the width is squared, and the height squared. The length is squared, the width is squared, the height squared is 12 times 15 times 20. Let's continue this on the top. I'm going to take the square root of both sides. We're going to take the square root of both sides. So square root of length squared, width squared, and height squared equals the square root of 12. 12 can be written as 2 times 2 times 3, that's your 12. 2 times 2 is 4, 4 times 3 is 12, that's our 12. 15 can be written as 3 times 5. And 20 can be written as 5 times 2 times 2 if you like, or 5 times 4. There is your 20. There is your 20. And now we take the square root, that's what it is. And therefore square root of length times width times length squared, width squared and height squared is simply length times width times height. And the square root of this quantity is going to be, let's find out. The square root of this quantity is going to be, here I see 2 2's, so that's the 2. Here I see 2 3's. Here I see 2 3's, so that's the 3. Here I see 2 5's, so that's the 5. And finally I see 2 2's, and that's the 2. That's it, that's your volume. 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60, same as before. And this is more of a mathematical way of doing it, more algebraic way of doing it, in a more abstract way. Instead of having to worry about what we were doing the nonsense before, the childish way where I showed you all 3 different scenarios to convince you that it doesn't matter which side you call what, it's not going to change anything. Alright? I'll see you tomorrow. Bye now.